Welcome to lecture CO4. Theme is ventilated facade or ventilated walls. In this system, we will talk about the solid ventilated wall systems, and we will talk about the skeleton-like ventilated wall systems in this lecture. We do divide mainly these ventilated systems A by the substructure, as just explained, solid or skeleton, and B by the outer layer of these ventilated system. Such a ventilated system works in this case. We have this functional zone, load-bearing area, plus the insulation layer. We have the outer cladding, which is the rain screen, the outer rain cladding, which is positioned with a ventilation cavity. This ventilation cavity allowing ventilation to get in and out. And we have the inner airtightness layer, which needs to seal the wall system versus humidity from inside, something which we need to take care of very carefully to make sure that there's no humidity from the inside penetrating our system, ending up in the wall. If this humidity ends up in the wall, we need to make sure that it's still openable enough, breathable enough to allow the humidity to get out of the system. We can divide these ventilated cladding systems by horizontal or vertical cladding system with a substructure system. This is a masonry system, which obviously also needs a substructure, some brackets to take the dead loads of the masonry into the main structure. A metal cladding on a subsystem or a metal cladding on a bracket system, which say individually keeps the positions of the outer cladding layers. The masonry system, as just explained, we see this masonry set, the functional zone, the outer cladding, the inner airtightness, and here we see in the middle picture, we see how it is made in reality. We see the main structure being a prefab concrete system here. We see the insulation layer here, and we see the masonry being brought in position. We also have to identify that the outer masonry needs to be held in position because it's so slender that it will not be able to stay in position and not buckle by being horizontal loaded, which means that you have to have these connectors between the outer masonry system and the inner main structure, which have to penetrate the insulation, obviously, and which have to fix the insulation, which we'll see in a minute in one of the next slides. And yes, the window itself needs to be added. We see the outer cladding, we see the insulation and cavity, we see the inner structure, and we see the window itself as it is positioned in here. More details in one of the next slides. This is how it looks like when installed. We see the main structure, top picture, main structure of concrete. We see the insulation being poured in position. You see these dots. The dots are fixing the insulation in position. It's these rods which are brought into the concrete, then fixing the insulation with some plastic covers. And then the masonry structure, which is brought in front of it with a cavity and the final building as we know it. This is the more detailed situations. We see the outer masonry structure, we see the insulation, we see the insulation fixing with the plastic cover cap, which keeps the insulation in position, and then this metal rod, which is brought into the masonry structure and then keeps the masonry structure in position with keeping the distance for the cavity in position as a system. And then of course on top we see pretty much at the top of the picture we see the concrete structure being brought in position. This is a Dutch sample which we can identify by seeing the window being brought in position before the masonry is brought in position, typical Dutch way of doing. We also see that there's a need of making sure that any leakage of the window, any water coming from the window needs to be drained out so that there's no additional water getting into the cavity. It always needs to be drained with the windowsill drained to the outside of the system. Same technical detail. We see the masonry structure, we see a window being brought in position, and we can identify this needs to be brought in position so that any leakage does not penetrate the inner insulation and stays in the system and then finds its way out of this structure. Same for this situation, left picture. Here we see the window frame being brought in position. They always have to be brought in position in, say, similar area of the insulation. To secure that, it needs some structural support, which are these brackets, the window support, these brackets which are fixed to the main structure, keep the window in position, and then this whole thing is sealed with an outer windowsill and an inner windowsill to close these systems. The dead loads of the outer masonry structure needs to be taken to the main structure. That's what we see happening here. So we see the masonry structure, it brings down its dead loads to this rail, and this rail actually brings down its structural loads to this bracket. The bracket is then fixed in a rail system into the main structure of the concrete. It could be actually horizontal in all directions, adjusted here. You even can adjust the angle by tilting it to the outside or the inside as a position to take down the dead loads of this masonry structure for the outer cladding. We see the insulation, we see the fixing devices, the rods brought into the concrete directly, keeping the insulation in position, penetrating the sealant from the window for the drainage for the window, and then keeping the outer cladding of the masonry structure in position by being mortared into it as a system. When we go from the solid to the skeleton structure, structure with rain screen cladding are done this way, that we have a main inner system, which is the functional zone, load-bearing structure, insulation structure, and outer cladding and inner cladding to keep that main structure as a structural component, and then having a rain screen cladding at the outside and an inner cladding at the inside to create an inner surface, which we discuss in a minute as a system. Samples, this is a project in Rotterdam, and how it is done in detail. This is a detail drawing of this situation. We see using this same setup being brought in here. And when we come to the window itself, this is always where the interfaces do happen. This is always where the, say, interesting connection needs to be developed. We see the window being brought in position in the area of the insulation. We see also the window being brought in position in the area of the insulation. The outer window sill and the inner window sill closing this surface. So this could be done in a more stretched detail. This stretched detail is the same moment to explain a bit how this system works. We have the main structure, we have the insulation, we have an outer cladding to close this main structure, we have an inner cladding to close this main structure. This inner cladding has to fulfill, next to the structural part, also the functionality of being airtight. As said, inside needs to be airtight. The outer one has to fulfill the structural function, but also being breathable, which means we have an additional layer here to secure that this is not airtight but breathable as a system. Then there's the cavity in between, so that cavity part, and then there's a prefab system, some rail system which keeps the outer rain cladding in position. We also see that there's an inner layer, which is again added on some substructure. This happens because we want to be able to install any electricity devices, and by installing these electricity devices we need to penetrate the inner layer. And by penetrating the inner layer, if this would be the sealed layer, we would create openings which would end up in humidity coming from the inside, penetrating these openings and then getting into the main structure, which we need to prevent. We need to make sure the inner layer is airtight. To do so, we add this additional layer at the inside, being able to install any electricity devices, and then having a separate layer entirely sealed, airtight sealed, to enclose the main structure, insulation and main structure, and prevent it from humidity finding its way into this system. This is a sample of this outer rain screen. It's a ceramic tile with a certain fixing device, which is here, which is then added on a rail system, which we see here. The hooks find the position and keep the cladding in position as a system. The cladding can be done in various materials, as we saw here. This is a ceramic system. The top one is clipboard. It's laminated aluminium sheets. The bottom one is natural stone. You can imagine that certain materials require certain thicknesses of structure. And they all have to be brought back with their loads into the main structure, so they need to penetrate the breathable membrane to allow their structure's load to be brought into the system. But it does not penetrate the inner airtight layer, which needs to be entirely sealed and airtight as a system. This is literature as usual, and again, I'm going to stop here.